All right, we are on to exercise 7 from the surface area and volume notes for a pyramid. And this question is asking us to find the exact volume of a regular hexagonal pyramid. And then the base edge of that pyramid is 8 meters and the lateral edge is 10 meters. So right off the bat, we have a question kind of asking us to think about the vocab of a pyramid. And then another key idea from the problem is the fact that we need the exact volume. So we need to stay away from using right triangle trigonometry. We'll have to kind of notice as we go through it, like how we can keep the answer exact. So it's always nice to have a diagram. Sometimes we get really caught up in drawing like the pyramid. It doesn't need to be a perfect picture, but just something that will do. So if we have the hexagonal base, I like to draw like the first 3 sides of it, like the 3 sides if I was looking straight onto this pyramid. And then I could put like a vertex point up there. And I have a lateral edge, another lateral edge. So there's one isosceles triangle, there's the second one, there's the third one. And then I like to use like dotted lines in the background to show like, okay, there's some stuff back there. We just wouldn't be able to see it from this view. And like I said, I'm not an artist, so this picture is not great, but it does enough for me to be able to solve the question. And that's all I really need out of my diagram. So, we know the volume of the pyramid based on what we kind of figured out above. The volume of a pyramid is equal to 1/3 the area of the base multiplied by the height. And now remember, when we're talking about a height of a pyramid, we're talking about vertex to the center of the base. The base is a regular hexagon. If we go back to the last unit, we should know that a regular hexagon is made up of 6 equilateral triangles. So here I'm just going to draw that hexagonal base. That hexagonal base, each side length, because it has a base edge of 8, meaning each side length of the hexagon base is 8 units long. Okay. If we need a recap of why there's 6 equilateral triangles in there, well, if I find one angle of the hexagon, an interior angle can be found by taking 180 times the number of sides, which is 6 minus 2. That'd give me the sum of all the angles, but if I divide that by 6, so I'm taking 180 times 4 divided by 6, I'm going to get each interior angle to measure 120 degrees. If each interior angle measures 120 degrees, and then I draw in the radius of the hexagon, the radius of the regular hexagon would cut that 120 degrees in half, which is 60 degrees, 60 degrees, and 60 degrees. So I get equilateral triangles all over the place here. So that 120 is cut up into 60 and 60 all the way through this picture. So I get 6 equilateral triangles. Well, since the given tells us that the base edge is 8, then we can solve for the area of the base really easily. So the first thing that I'm going to do is find the area of the base of which is the regular hexagon, which should be 6 equilateral triangles. And if we remember the equilateral triangle, so the area of the base is going to be 6 equilateral triangles, and the equilateral triangle formula is the side squared times √3 divided by 4. Okay. So in this case, I have 64 divided by 4, which is 16. 16 times 6, which is 96. So the area of the base is 96 √3 units squared. Oh, in this case, meters. So I'll change that to be meters squared. Okay, so we have the area of the base. Now we need to get the height of the regular hexagon. Of the regular right hexagonal pyramid. So we need to get the height. Well, let's kind of work inside that picture now. So we already know that we have a 60-degree angle when we draw in like that triangle. That's straight from here. So if the side is 8 and I draw in the apothem, I'm breaking 8 up into 4 and 4. So this would be 4. This is a 60-degree angle, so I have a 30, 60, 90 triangle. And the side opposite of 30 is 4, so then that means the apothem is 4 √3. Okay, I'm kind of writing really small there, but if the side opposite of the 30-degree angle is 4, then the side opposite of the 60-degree angle is 4 √3. Okay, well, the other piece of information they told us was that the lateral edge is 10. Well, go back to our 30, 60, 90. If this is 4 root 3, that one actually, the apothem actually isn't as important to me. It's this radius that's going to be important to me, and this radius is going to be 2 times bigger than 4, which is 8. We already knew that because it's an equilateral triangle. We already said that. And the reason that that's important to me is if I kind of think about what I have, they told me that the lateral edge is 10. That's this length there, right? Now, the radius is 8. The height drawn from the vertex, right? So I'm going to use a different color for that. The height drawn from the vertex to the center of the to the center of the hexagon would make a right angle with the radius. So there's a right triangle formed by the height of the pyramid, the radius, which is 8, and the lateral edge, which is 10. So I'm going to bring that to step 2 there. I have the height, the radius of 8, and the lateral edge of 10 make a right triangle, and that's a 3, 4, 5 right triangle. So that means that the height should be equal, it's 2 times bigger than the 3, 4, 5, so it's 3, 4, 5 scaled by 2, so the height is equal to 6. So that means I can kind of finish this problem now. The volume is equal to 1/3 the area of the base, which is 96 root 3, multiplied by the height of 6. Well, 1/3 of 6 is 2, right? So 1/3 of 6 is 2, and 2 by 96 root 3 should be 192 root 3 meters squared. So the volume of the pyramid is equal to 192 root 3 meters squared.